Good afternoon, everyone. First of all, welcome to this session. My name is Amitabh Tamhain. I'm a program manager with the Failover cluster team. I will be speaking about configuring Failover cluster Quorum for your private cloud deployments. If you have questions like, how should I configure the quorum of my clusters that I'm deploying in my data center? Do I need to configure a witness? What's a dynamic quorum? That's a new term that I heard about cluster quorum, and I want to understand what it is. Things like that, and more importantly, if you're deploying a disaster recovery DR solution, what kind of quorum configuration you need, especially around like manual failover versus automatic failover, what kind of workloads. Those are some of the questions I would be covering in this session. And I'm hoping at the end of the presentation you would have a clearer understanding to make those decisions. As a full disclosure, since the title has the word private cloud, Failover clusters, which is part of Windows Server, is the infrastructure for private cloud. So I am going to speak about the quorum model for the failover clusters. This session is not about the high-level private cloud, what it is, and so as a disclosure, I'm not going to cover anything about private cloud as such. The contents of the presentation are with respect to Windows Server 2012 and Windows Server 2012 R2, which is going to be released sometime this year. If you have Windows Server 2008 and Windows Server 2008 R2, some of the quorum basics as well as the functionalities like node vote weights may still be applicable. The guidance may differ based on new features, like we introduced dynamic quorum in Windows Server 2012. And so this deck, the way I'm presenting, is assuming you have a Windows Server 2012 and a Windows Server 2012 R2 releases. So I would be covering the quorum fundamentals and the basics, like what are the different types of quorum models you may potentially have, what are the voting elements, and things like those at the beginning of the presentation. If you have disk witness and a file share witness, what considerations you may have to make to appropriately decide whether you need a disk witness and a file share witness, those also would be covered. New features like dynamic quorum, as well as new features like the dynamic quorum for witness, which is the dynamic quorum for witness is new in 2012 R2. And I would be speaking about those features. I have a demo for that as well, and then I would be going over the configuration of cluster quorum, the actual how a step-by-step walkthrough for the quorum configuration. And lastly, for the disaster recovery multi-site deployments, I would be going in depth into how as a step-by-step walkthrough for that as well. So when you deploy a cluster, some of the challenges that actually affect the availability of the cluster itself can be something like if a node is being shut down for patching. If there is a script that you're running or an admin runs, it takes down a node at a time and patches the cluster. But if you take down enough nodes, the cluster may potentially go down. And so that can be a challenge from a cluster's availability point of view. The nodes may actually crash, or they may lose connectivity. And so if a node is lost, it affects cluster's quorum calculations, and how you guard yourself against these events comes down to how your quorum configuration is appropriate. So a strong quorum configuration helps you guard against some of these challenges. Similarly, if you add a node or evict a node, there are questions like, should I revisit my Quorum configuration? Should I revisit my runbook that I went through all these steps? And so the short answer, we have done some good steps in terms of add node and everything. So the dynamic with Quorum simplifies that experience a whole lot. And so those are some of the challenges I have captured in this slide. So the goal is to really ensure that the cluster stays up. If the cluster is up and running, the applications hosted on top of the cluster are up and running. So if you have VMs deployed or if you have SQL Server deployed, the availability of that hosted services depends on the cluster's availability, and the availability of the cluster depends on the Quorum configuration that you have in the cluster. So having a solid Quorum configuration is a must-have. You may ask, why do I need Quorum? The short answer is it gives a cluster a starting point in which it can start hosting applications. So if you are cold starting a cluster, let's say I have a 4-node cluster, and I'm starting this 4-node cluster, and at what point of time can cluster say that, yes, I can start the applications that I've hosted on this cluster? And the answer to that is once the cluster achieves a sufficient majority, that's the time cluster can authoritatively say that, yes, I can start hosting the applications. That also gives a guaranteed point that there is no partition or split brain in the cluster that it starts 2 instances of your applications. So you don't want that. And so that's where the Quorum comes and helps you address that. So in terms of Quorum goals, that when we started to work on Windows Server 2012, as well as Windows Server 2012 R2, an overarching goal was to basically make Quorum configuration simple. We have heard so many cases where people got confused, or I have these 4 Quorum models, node majority, node and disk majority, node and file share majority, which model is applicable under what configuration. Now I am considering to add a new data center, and I am extending my cluster to become a stretch cluster. Which model is applicable? What should I do? So all of that we are trying to, the goal was to really simplify all of that experience, to give a step-by-step, simple enough experience around that. So with that context, we have updated not just our UI, but also the Quorum wizards. That the Quorum wizard is the actual tool that you can use to actually configure the cluster's Quorum. In terms of PowerShell, we have made those improvements as well. And availability of the cluster. As I said, availability of the cluster affects the availability of your applications. And so we have introduced new features like dynamic Quorum and dynamic Quorum for witness that increases the availability of the cluster significantly. That enables cluster to actually survive in less than 50% of the nodes in the cluster, which was not possible before. So in more scenarios, cluster would now survive and continue to host applications. And lastly, we wanted to enable more disaster recovery scenarios in the same lines as increasing clusters availability. So just a quick recap of in cluster, as a simplified messaging, we are no longer talking about Quorum models. So there is only one Quorum model, and that is a simple majority. And a majority of what? And the what is the voting elements. And there are 2 types of voting elements, a node and a witness. Each node, by default, gets 1 vote. And that's configurable. A witness, when you configure, has a vote. And so now if I have 5 nodes in my cluster and I have a witness, I have a total of 6 votes. And a simple majority is like 4. With dynamic quorum, the majority would change, and I'll be going over in detail about those scenarios. But really, that's the simplified message, where it's a simple majority, and these are the only two types of voting elements. Now, in terms of witness, what type of witness do clusters support? There are just two types of witness. One is a disk witness, and another is a file share witness. A file share witness is just an SMB share that you can host on a file server. In terms of disk witness, we expect it to be a dedicated LUN for cluster. It can be a small size. What cluster does is it writes a cluster database, which is a replicated state, to the disk witness as well. And this disk witness actually has it's a voting element, and it can support both NTFS as well as REFS partitions. You don't have to configure any drive letters for this disk witness. So that in terms of configuration, it's a simple dedicated LUN formatted with NTFS or REFS, and you tell the cluster saying, okay, use this disk as my quorum witness, and cluster would happily run from that point on. And please ask any questions you may have as we go through the presentation. And one point I would mention is, let's say I have a 2-node cluster, and if the nodes are not able to talk to each other, there is a connectivity break. The two nodes use this disk witness as the arbitration point. And so both the nodes try to reach to that disk witness and use the SCSI-3 persistent reservations to actually arbitrate ownership of the disk. And cluster has this built-in arbitration algorithm, which uniquely determines who's the victor in terms of the two nodes. And you can imagine you can have two partitions with n nodes, and they would still do the same thing. They would try to reach the witness, and the witness the winning partition would have the witness successfully arbitrated. In terms of file share witness, like I said, it's a simple SMB share that's hosted on top of a traditional file server. This SMB share, this file server can be used to carve out multiple shares for your different clusters. However, each SMB share is expected to be dedicated for an individual cluster. So what cluster does is it goes ahead and uses that SMB share. It uses the computer name object that it created in the Active Directory, and it uses those permissions to access that SMB share. And so you have to make sure that the computer name object, which is created in the cluster, the domain, Active Directory domain of the cluster, has access to the file share witness. But when you configure file share witness through UI, cluster does those permissions configuration automatically. As long as you as an admin have access to that share, cluster configuration would take care of that step for you. And so that's about the file server and the SMB share. But where should this file server be running? The location of this file server is expected to be on a separate node, which is not part of the cluster that the witness is, because you want to give certain guarantees where cluster can automatically fail over across different partitions. And if a node of the cluster goes down, you don't want the file server to go down so that your witness is also lost. And as I said, that it cannot be a VM that's hosted on the cluster to which you are configuring the witness and that becomes like a catch-22. In terms of Azure persistent VM based file server, that's something we have not tested per se, but I'm told some people have actually managed to configure a file server in a persistent VM in Azure, and have that SMB share access for your private cloud cluster. And so I don't have enough details around that scenario, but I'm told that's possible. And the key difference between the file share witness and a disk witness is it does not have a copy of the cluster database. And so what happens is, let's say a cluster which is making, you make a configuration change. The configuration change gets replicated to all nodes in the cluster. If you have a disk witness, that replication change gets written to the disk witness. Every time there is a cluster database update, the disk witness is accessed and it's written. But in case of file share witness, it's over the network. And so we don't actually store copy of the cluster DB in the file share witness, so the network usage is actually fairly light. So partition in time. So I have a 2-node cluster and a disk witness configured. And let's say my node 1 is actually down. Actually, in this case, node 2 is down. Node 1 makes an update, let's say the state of the role, and it gets updated in the cluster database, which gets recorded in the disk witness copy of the cluster database. And now what happens if my node 1 also goes down? At this point, cluster's down. But if I start node 2, then if I start node 2, that's the partition in time where node 1 and 2 never really talked with each other, even though they are part of the same cluster. However, the common entity is the disk witness, and node 2 uses the copy of the cluster database in the disk witness to actually start from where node 1 left off. And so that's disk witness enables a recovery from a partition in time scenario. So now what happens if I have a file share witness instead of a disk witness? I attempt to start my node 2. However, it recognizes that the timestamp that's recorded in the file share witness is actually later than the timestamp of the cluster database that I have on my system. And so it has that awareness that my database is not latest. And so if I start now, I may potentially lose any changes that node 1 may have made. And so that's where it stops. And you won't be able to start the cluster service as a simple start. But the file share witness helps you basically prevent partition in time, essentially loss of configuration. But it does not help you in recovering from that situation. Yes? So if the node 1 is really down and you cannot recover, you can always force start cluster on node 2. In terms of force quorum as well as the recovery actions, I am covering that in the later slides in the disaster recovery section. But yes, absolutely, you can start it manually. But that means at that point you're saying, I know what I'm doing, and it's OK for node 1's updates to be lost. So in terms of preventing split brain or providing an arbitration point, both disk witness and file share witness are perfect. In terms of preventing partition in time, both the type of witness work just fine. But in terms of recovering from partition in time, disk witness helps simply because it has the copy of the cluster DB. And the arbitration type is slightly different, where we use SCSI-3 persistent reservations for disk witness. And for file share witness, we have this witness.log file that cluster writes in that SMB share. And cluster uses the cluster name object in the Active Directory as the authoritative that has the access to that file share. And this witness.log file has the timestamp as well as who's the current owner. And so that's how cluster nodes or cluster partitions can arbitrate using the file share witness. In terms of recommendation, if you have shared storage for all your nodes in the cluster, the recommendation still remains as a configure a disk witness. Simply because it has a copy of clusterdb and it can recover from the partition in time. If you have a disaster recovery or multi-site, multi-data center deployments, then configuring file share witness is actually recommended. Node vote waits. This is actually a new feature that we introduced in Windows Server 2012. This is also available as a QFE for Windows Server 2008 R2, and it's also part of 2008 R2 SP1. What node vote waits does is it gives you the ability to toggle whether or not a node actually has a vote. What node vote wait does is, let's say I have a set of nodes and I have a disaster recovery site that should come into play only when my primary site goes down. That's like a manual failover scenario. You may come in and say that I don't want that disaster recovery node to affect the stability of my primary site cluster. And so you can actually remove a node vote of the disaster recovery site node manually, and cluster would honor that. And so that removes that disaster recovery site node from the cluster quorum calculations. And in terms of configuration, it is done per node, and so you can actually have a more finer setup. So in terms of cluster database replication or the ability to host workload, the node whose vote was removed by the user, that continues to be very much part of the cluster. It still gets updates of the cluster database. It still can host workload. It's just not participating in the cluster quorum. I actually did cover the scenario under which you would set node vote weights, but really the punchline is you have some nodes which are less important than the other nodes, and so the less important nodes vote would be taken out as part of the as a configuration step. And let me repeat, that step becomes necessary only for your disaster recovery multi-site deployments when you have a manual failover requirement, like your SQL clusters that require a manual failover between sites. So now consider a scenario where I have 4 nodes in my cluster and I remove one of the nodes vote out. So node 4's vote is actually taken out by the user configuration. If the node 4 goes down, it does not affect the cluster. But if I lose node 3, then also it does not affect the cluster, because the majority was reduced down to 2 when you removed node 4's vote out. In terms of configuration, you can have you can do it through PowerShell or through Cluster Quorum Wizard. I would be demoing this Cluster Quorum Wizard configuration in few slides later. But it's really a simple checkbox. You simply uncheck the nodes which you don't want to have votes, and cluster would configure those, remove the node's votes. By default, every node always has a vote. So out of the box, when you install Failover clustering, when you create a cluster, all nodes in the cluster have a vote. And when you want to remove a vote, you just set a value of 0 to the node vote weight. In terms of, so I have still not talked about dynamic quorum yet, but in terms of viewing which nodes actually have a vote, which nodes don't have a vote, we have updated in 2012 R2 release the UI for nodes. So in the new UI, you have two columns right next to the node names that tell you the user intention, like user configuration. So that's the assigned vote column. And then the clusters assigned or cluster managed voting for individual nodes, which is the current vote column. If you have, so there is a validate quorum configuration validation test. If you run that test after you have configured a quorum wizard, you can also see this in this nice tabular fashion. So let's talk about dynamic quorum. I have, so I talked about node vote weights where user has to manually go ahead and actually configure a node's vote to be 0 or 1. In case of dynamic quorum, what cluster does, it actually automatically toggles nodes' votes for you, but it uses a different algorithm. It uses the state of the node as the cue for deciding whether the node actually has a vote or not. And so if the node is up and running and user did configure to have a vote, cluster would assign a vote of 1. If the user configured a vote of 0, cluster would honor that and keep the dynamic vote as 0. But if the node, let's say on a steady state, a node crashed, and the user had assigned a vote of 1, cluster would automatically remove that node's vote out. But you would ask me, why would cluster do that? What does the benefit that actually helps in terms of stability of the cluster, in terms of availability of the cluster? The answer is, if you, without dynamic quorum, let's say in my 2008 R2 cluster setup, once you configure a cluster, I have, say, 8 nodes, then the quorum majority is fixed. I need exactly 5 nodes or 5 votes for cluster to be up and running. With dynamic quorum, based on the state of the nodes, when cluster adjusts nodes' votes, it adjusts the majority or the total number of votes that are actually required for cluster's quorum. Because the total number of votes are adjusted, the majority requirement of the quorum is also dynamically calculated based on using the dynamic quorum logic. And so now, in my 8-node cluster example, if I lose 3 nodes and we are down to 5 nodes, cluster had removed the 3 nodes votes out, and so my total number of votes got shrunk to 5 without user configuration, and the majority became 3. And so now cluster can sustain 2 more nodes that can go down. And so this is the new scenario where cluster can survive in less than 50% of the nodes that you initially configured. So now, at what point of time does cluster stop adjusting these dynamic votes? The thumb rule is cluster requires the existing majority to make changes to quorum calculations. And so as long as cluster has enough majority right now, it can reduce the majority for the next step. And so if you have a 64-node cluster, you may lose or you may shut down sequentially 1 node at a time all the way down to last node. And that's your last man standing scenario. Of course, not all the 8,000 VMs that we support would be running on that node, but at least the cluster's up and running, you can start taking some good steps. In terms of features like node vote weight, as well as force quorum, cluster automatically has the integration or seamless integration with this feature. So cluster, if you force quorum on a node, dynamic quorum would start at appropriate times, and the cluster would start resuming in normal functioning at a later time. And I would be talking about those scenarios in the disaster recovery section. In terms of configuration, dynamic quorum is enabled by default. So you have no configuration step necessary for this functionality to be available. Out of the box, this is enabled, and we strongly encourage to keep it that way. Dynamic quorum for witness. This is something new we added in Windows Server 2012 R2. Dynamic quorum by itself was added in Windows Server 2012, but that only affected the state, only affected the set of nodes in the cluster based on their state. But with dynamic witness or dynamic quorum for witness, cluster can now toggle the vote of the witness based on the need. When I say based on the need, you have to, I have to clarify one point, and which is, historically, those of you who have been using clusters, we have always, the guidance has been, if you have even number of nodes, configure a witness. If you have odd number of nodes, don't configure a witness. The intention behind that is to keep the total number of votes odd. But with this feature, what cluster does is, irrespective of your node, if you configure a witness, cluster decides whether or not to use witness vote. So if I have even number of nodes, if I have 8 number of nodes, and you configure a witness, cluster decides to use the witness. But let's say I have only 5 nodes in the cluster, and you'd configure a witness. So now you have actually configured 6 votes. Cluster automatically removes the vote of the witness. And so you still have 5 nodes that have votes, and so the cluster automatically keeps the total number of votes odd. How does that help? It greatly helps in removing one question, which is whether or not I should configure a witness. The answer is, you always configure witness. You may choose to decide not to if for reasons, for any specific reasons, like you know it's a local site, a witness failure would unnecessarily trigger critical system events, and we don't want those alerts. But really, if the cluster has with this feature, cluster can decide whether or not the witness is required. And so that way, tomorrow when you add nodes or remove nodes, you don't have to reevaluate the quorum requirement. Cluster would take care of that for you. Excuse me. So let's look at some of the cluster properties or the quorum properties. In terms of user configurable properties, there are really only 2 properties. The first is whether or not you want dynamic quorum. The dynamic quorum is enabled by default, and if you really want to, you may choose to opt out by setting the value of 0. Node vote weight. By default, every node has a vote of 1. A value of 0 indicates the node's vote is removed as a user intention. Both of these can be changed using PowerShell. The node vote weight can be modified using Windows Cluster Quorum Wizard, which is the UI portion. There are 2 more properties that actually affect quorum, but those are really a cluster managed properties. Those are the properties that cluster decides to assign a particular node a vote or not. So that is indicated by dynamic weight as a property of the node. The value of 1 indicates the node has a vote. The value of 0 indicates the cluster has removed the voting capability of that node. This property is a read-only property, so you can't change it. But when in the UI section, when we saw the new nodes page, the second column, which is the assigned or the current vote, maps to this dynamic weight property. And in Windows Server 2012 R2, with the dynamic witness feature that I just talked about, we are adding this new property, which is witness dynamic weight. That is similar to dynamic weight of the node. It tells you whether or not cluster has assigned a vote to the witness. Both are read-only properties, and that's the partial syntax to access it. So now let's look at some of the scenarios. So I have a cluster that's up and running, and I decide to shut down a node. In that case, the node, before it shuts down, announces to the remaining nodes in the cluster saying, I'm going down, please remove my vote. And that gets recorded in the cluster database. When a node is coming back up and it joins back to the cluster membership, it announces to the remaining nodes in the cluster saying, I am up and can I have my vote back? And the cluster actually assigns the vote back to the node. But in case of a node crash or a node failure, the node does not get a chance to actually make that change. So the remaining nodes in the cluster decide that node has gone down, and we are going to remove that guy's vote out. To make that assertion, the remaining nodes in the cluster have to have the existing majority so that can be recorded appropriately. In terms of witness scenarios, if with the dynamic witness work, if you have even number of nodes in the cluster or active nodes in the cluster gives witness a vote. If you have odd number of votes active in the cluster removes the witness vote. This is irrespective of the state of the witness. But if the witness has actually failed, cluster does remove the witness vote out, irrespective of the count of the nodes. So that's because if the witness has gone down, you don't want it to affect quorum calculations. And then there is the tiebreaker scenario that I would talk about in the next slide. So that's a list of witness scenarios. But witness, once it comes back up online, cluster again evaluates based on the active membership whether or not to give witness the vote back. So tiebreaker scenario, which is also a new feature we have added in Windows Server 2012 R2. What this gives you is basically with the same goal of keeping the total number of votes odd, cluster, if the witness, let's say I have configured my cluster, I configure a witness, and witness has failed. Cluster removes the witness vote out, but now I'm stuck with this even number of nodes in my cluster. But I still want to achieve that odd number of votes guarantee. The cluster then automatically or selects a node, and the node selection is random basically, and it picks a node saying, yes, you are the node whose state is still up, but we are still removing your node vote out. So the node weight remains configured 1, but the dynamic weight is made 0. Now consider a scenario where I have a stretch cluster with a multi-site deployment, and I have 2 nodes on both the sites. And say my file share witness has failed or not configured for some reason. Cluster identifies that all nodes, there are even number of nodes, and it automatically picks a site or automatically picks a node whose vote to be removed. And so in this case, my node 4 in site 2 vote was removed. And so now, if there is a WAN link connection break and my site-to-site communication breaks down, previously cluster would go down because it required 1 node at least from the other side. But in this case, the majority was shrunk to 2, and cluster on site 1 would win, and site 2 would go down in a scenario where there is a WAN link connectivity break. Any questions around this? Yes? Can you speak a little louder? So by default, it picks a random node. But if you want to control which site wins, there is this property that says that's a really long name property. That says that an ID of a node whose vote to be taken out. So the intention is, once you configure this property with the ID of node, let's say I want to give favor site 1 instead of site 2. And I remove node 2's vote out. So I would set this property with node 2's ID. And so that way, cluster picks that node to remove a vote out. But if the node 2 is down, then cluster would automatically pick a random node. So, yes?
What happens if you have a 4-node cluster with a witness disk, and the witness disk fails?
Yes.
Does the cluster then decide that one cluster node needs to be shut down in order to have an odd number of cluster nodes?
No, the node is not shut down. The node remains up and running. The dynamic weight or dynamic vote of that node would be taken out. Actually, your question is extremely relevant for my next slide. Let me walk you through that. And you may ask your question if it's still not clear. So I do have a 4-node cluster, and I do have a witness. And so majority was 3, and I had a total node of 5. But what happened, let's say my node 4 fails. So the cluster removes the vote of the node 4. And so now, together with the witness, cluster has even votes. In that case, because of the dynamic witness feature, cluster removes witness vote, and that's what happened here. And so the total was reduced to 3, and so now cluster can sustain one more node failure. And that's what happens. Let's say my node 3 goes down. We are down to 2 active nodes, but witness is still online, it's still functioning, and cluster has arbitrated for the witness. So witness vote is given back. So that way, cluster keeps that total number of votes odd. And now what happens if I lose node 2? That's your last man standing scenario with a 4-node cluster with only 1 node surviving. The one thing I would call out is, don't be surprised to see node 2's vote still there, even though the state of the node 2 is down. That's because of the partitioning time scenario where we want to allow node 2's to start. If, let's say, node 1 is the last man standing and that crashes, you still want at least have one more node to start the cluster. So that's why that vote was kept as is. Yes?
Is that possible to achieve the same scenario, last man standing, under 2008 R2?
For 2008 R2, it's not possible because dynamic quorum is not there. This is achievable only because of dynamic quorum. This feature is achievable in 2012, like Windows Server 2012, as well as the release that would be released this year, but not in 2008 R2. The node vote weight, like a manual configuration, is present in Windows 2008 R2. You can remove nodes votes using the node vote weight functionality in 2008 R2, yes. But not the automatic cluster dynamic managed, not the dynamic quorum functionality that cluster has. So let's look at, let's say I didn't configure a witness, or my witness had failed, and I have 5 nodes in my cluster, and I have odd numbers, so everything's good. I lose 1 node, its vote was taken out. But my node 4's vote was taken out because of the tiebreaker scenario. But now if my node 4 goes down, no changes happen. Everything just keeps on running. And if I lose node 3, its vote would be taken out, and the 2 remaining nodes in the cluster, and the cluster survives on the 2 remaining nodes. However, you may observe that node 2's vote was taken out. So this is slightly different than when you have a witness configured or witness is up and running. If witness had failed or you have no witness configured, then in that scenario, a cluster automatically picks a node to remove its vote out and achieve the last man standing. So in this case, 3 things can happen on a high level. The 3 things can happen. Node 1 may go down, node 2 may go down, or there may be a communication break between node 1 and 2. If there is a communication break, cluster would survive on the last man standing, which is node 1. If the node 2 goes down, things remain fine, cluster survives on last man standing. If node 1 goes down, cluster would go down. If you gracefully shut down node 1, it just works fine. The vote get exchanged to the node 2, and cluster allows node 1 to shut down. And so in many scenarios, so like even in this case, there are 3 out of 4 scenarios cluster has the ability to survive. And let me just call out that this scenario of the last 2 nodes when there is no witness is actually present in Windows Server 2012. In fact, that's a scenario we expanded to any even number of nodes in the cluster for the tiebreaker scenario. So in that scenario, if you look at the properties, you would see that the state of both the nodes is up. The user configured node weight is 1, and only one of the nodes' vote is actually made 0. So let's hope my demo works. Just a second, because my laptop shut down on me while I was speaking. It's connecting. All right. So this is running Windows Server 2012 R2. So that's the new UI dashboard. For those of you who have been using clusters before, you would notice there is no Quorum information that would be listed on the dashboard. You can still find that information used by running a validate Quorum configuration, because it gives you more insight into what's really going on in your cluster. If I look at the nodes page, that's where I see I have 5 nodes in my cluster. I have all the nodes are up and running. The assigned vote, which is node vote weight, is 1, and dynamic vote, which is also 1 for all the nodes. If I go back to the dashboard, I have my Quorum witness configured, which is cluster disk 1. And this is the cluster group. In the disks page, it also clearly calls out saying this is my Quorum or disk witness. same information is, I can see that using PowerShell, and this is what I have captured here. So now let me stop a couple nodes. So what just happened, the state of the nodes went down, the user configured vote remained 1, but cluster managed voting, or the dynamic weight of the node, became 0. In this case, I still have my 3 nodes in my cluster which are up and running. So if I look at the dynamic weight of the witness, it still is 0, but my witness is up and running. Now what happens if I shut down one more node? So its dynamic vote was also taken out by the cluster. And by the way, cluster is surviving in less than 50% of the nodes, which is the dynamic quorum scenario. And now if I look at the witness dynamic weight, this has become 1. And so cluster recognized the fact that I have 2 nodes, which is even, and cluster assigned the witness vote back. And if I take down one more node in my cluster, notice it went down, but its dynamic vote remained 1, which is the scenario I was talking about, where to enable partition in time with disk witness, we keep the vote up. And so the witness vote also remained 1. At this point, let me just start the nodes so that my next demo works. And this multi-select, right-click on the nodes is a new functionality which was added in Windows Server 2012 R2. So dynamic quorum considerations. That's good. So cluster can now survive on less than 50% of the nodes in the cluster. Cluster's availability is increased significantly with a set of nodes, and also the availability of your applications. However, there are some considerations. The first is, the thumb rule is cluster requires existing majority to make changes to the quorum, dynamic quorum calculations. And so if you lose more than 50% nodes simultaneously, let's say my site configuration was 3 nodes in one site and 2 nodes in the other site, and I lose the site that had 3 nodes, I just lost more than 50% of the nodes in the cluster. So the remaining nodes in the cluster do not have the authority to actually say that, okay, I can make the changes and enable cluster to survive. So that's one caveat that you have to understand. In terms of witness configuration, witness helps survive 1 extra node. With the dynamic witness, you always configure quorum witness. It's always goodness to actually have witness configured. In the last man standing scenario, or even the scenario where cluster is now surviving with less than 50% nodes, in a way you are increasing the importance of those nodes, because those nodes are surviving and have the latest configuration of the cluster. The nodes that are down are not talking to this cluster instance. They are not able to, the remaining nodes in the cluster won't have the latest cluster configuration. And so if you are doing all the way, let's say, down to last man standing, and if the last man standing node goes down, and you are not able to recover that node, then even with the n-1 majority, if you start the cluster, it won't start because it does not have enough votes. So that's something you have to consider. That cluster did survive on the last man standing, but you are not able to start with the majority of the nodes. So that should not be a surprise. But it's done for the right reasons, because the majority of the nodes don't have the latest cluster configuration. And at that point, using forced quorum becomes kind of necessary. I will just jump through this slide. The failover cluster veterans who have been using it since 2003, disk-only quorum is strongly discouraged. Because with a disk-only quorum, you have only one vote in the cluster, which is the disk's vote, and all the nodes' vote was taken out. And so now disk becomes a single point of failure. Versus with dynamic quorum, you have this dynamic majority that enables cluster to really survive in many scenarios. So essentially with dynamic quorum, you don't need the disk-only quorum configuration. I already covered a few of these. We have updated the nodes page to have a clear view of which nodes have a vote, what was the user intention. In terms of Quorum Wizard, we have updated Quorum Wizard to remove the 4 quorum models that in 2008 R2 you see this node majority, node and disk majority, node and file share majority. Those 4 quorum models are gone. You just have to make a decision about whether or not you need a witness. Let me quickly jump to the demo, but we have also updated the PowerShell command with the new parameters. So your existing scripts, if you have written, those would work, but those are deprecated. These are the new parameters which are simplified from the user intent point of view. So back to my demo cluster. So I start my quorum configuration. The first thing you would notice is there are no quorum models really, but there are these 3 options. The first of the option is really a reset to factory defaults. Essentially, cluster enables dynamic quorum. It resets your node vote configurations, essentially giving all nodes vote back. And if you have storage, which is shared storage available across all nodes, it also configures a disk witness for you. Essentially the same behavior that you get when you create the cluster for the first time. In the second option, the same steps are repeated where the dynamic quorum is enabled, the nodes' votes are assigned to all nodes, except that you are given the choice to configure an appropriate witness. If you want to configure file share witness, that would be the option that you would choose. Lastly, if you really want to configure all and tune all settings by yourself, you would use this option. So this is the node vote settings where by default all nodes have votes. If I really want to, I can remove a node's vote by simply unchecking a box. And on the next page, this is the new witness selection page where there are no, if you look at Windows Server 2012 or earlier releases, on the witness selection page, we used to tell you how many nodes you have configured, how many nodes have actually configured to have votes, and to make a decision based on even and odd voting. With the dynamic witness feature, the guidance is simple: always configure a vote, always configure a witness. And so this page has been updated with that intention. So we always recommend to configure a witness. The choice is yours, a disk or a file share witness. If on the next page, cluster automatically selects the smallest disk. and it gives a summary, and then it actually configures the cluster quorum. And the report also gets generated, which you can view later. There is only 15 minutes remaining, so I'm going through the slides a little quickly so that I can I can talk about the DR section. All right, so recovery actions. Force quorum, that's a tool that's a big hammer. In other words, it's a tool that in scenarios that we, as per the question earlier, if you don't have, the cluster cannot start, and if you don't have the nodes that have the votes to really start the cluster, at that time, starting the cluster using force quorum becomes necessary. So what you do is you go to a node and say net start / force quorum, or with a start cluster node, you can say that dash force quorum. So you start a node in a force quorum mode. The big warning sign is that when you start a cluster with a force quorum, cluster assumes that its admin is in full control, and so until enough votes are available for the cluster would remain in this force started mode. But as soon as there are enough votes that join the cluster back, cluster automatically gets out of this force started and it resumes normal functioning. Similar to force quorum, there is a second flag that you can pass to both the start cluster node as well as net start cluster service, which is prevent quorum. What prevent quorum does is it tells the cluster service on that node to not form the cluster by itself, but rather go talk to an instance that I have already force started. So in terms of recovery steps, you always force quorum on one node and do prevent quorum on all the other nodes in the cluster so that they join this force started instance. So you don't have this split brain or multi-partition scenarios that ever crop up. Force quorum resiliency. This is a function. This is actually a scenario that we have updated around force quorum in Windows Server 2012 R2. And with this functionality, what cluster does is actually, let's say I configure I have a DR site, multi-site cluster. On the DR site, I remove the nodes vote out. And on my primary site, all my nodes have votes. But let's say there was a site power outage and my primary site went down. As part of the recovery steps, I force started the cluster on my site 2. It's up and running, it's all golden, but the power comes back up on primary site. And in that case, primary site, it doesn't know about the force started instance. It has enough votes. It forms a cluster, it has quorum, it starts hosting applications. So previously, all the way up to Windows Server 2012, the guidance around that scenario was run quickly and stop the nodes on the primary site. So in this case, cluster does is as soon as the communication is established between the two sites, a cluster on the primary site understands that the timestamp that I had is actually older than the timestamp that the force started cluster has, and that was the user intention. And so the primary site nodes go down and restart using prevent quorum automatically for you. So that's a big enhancement around the force quorum resiliency we have made in R2. So let's look at the DR set configuration. We looked at node vote weights, we looked at dynamic quorum for nodes, we looked at dynamic quorum for witness. But when you look at the DR configuration, the multi-site, the first question I would ask is, what's your SLA? Whether or not you want a manual failover of the workload between the sites, or do you want automatic failover between the sites? That's an important question, because an answer to that question tells me whether or not all nodes are important or all nodes are not important. If you want manual failover, which means if the cluster on the primary side goes down, it's okay for the cluster on the secondary side to go down because I have to manually start it anyways. But with automatic failover, all nodes are equal, all sites are important, all the nodes have votes, and so the quorum configuration changes slightly. So that's the important question first you have to decide when you're deploying multi-site clusters. Let's look at the automatic failover considerations. So all sites are equal, all nodes have votes, so no node vote modifications necessary in this scenario. The file share witness has to be configured on a third separate site, because that gives you the guarantee that both sites have equal opportunity to actually survive in the event of a site-to-site communication breakdown. Because both the sites would rush to arbitrate for the file share witness, and only one of them is going to win. And you want to give the ability for both the sites to actually win. The number of nodes becomes an interesting scenario, because to give the equal opportunity to both the sites, you may have to configure the same number of nodes on both the sites. If you configure, let's say, 3 nodes on one side and 2 nodes on the other, you may actually lose the second side because you are always preferring the first side. If the first side goes down, you are losing a majority of the nodes. So having equal number of nodes is kind of important in this scenario. I already talked about the file share witness configuration. With dynamic witness, again, always configure file share witness. In terms of witness selection, if you really want, there are I think EMC has a solution where they have they provide a read-write access to a replicated storage on both the sites. I don't know if they still have it, but that was cluster requires read-write access to the disk to the LUN that is going to be used as a disk witness, and so on both the sites you want read-write access. So if typically on a multi-site cluster you have replicated storage, and so you have read-write access on one site and a read-only access on the other, and so that configuration is not supported for disk witness to be configured as a disk witness, and so that's where configuring a file share witness becomes a lot more important for multi-site clusters. That's just an example where I have 2 sites configured with a file share witness in my third separate site. And I have all the nodes actually have votes. Since I have equal number of nodes in the cluster in both the sites, the total's even, so cluster gives the file share witness vote. So everything's good. If my site 2 goes down, the cluster still survives on site 1. Now let's look at this from a slightly different scenario. There are at least 2 or 3 times when I was asked a question saying, what happens if really there is a site-to-site communication breakdown for all the 3 sites, where the 2 sites of my workload as well as the file share witness? How can I make sure cluster survives? Short answer, we have improved with the dynamic witness as well as the tiebreaker scenario a lot. However, if you lose connectivity, WAN link connectivity simultaneously on both the sites, the cluster would still go down because you have lost majority of the nodes at the same time. But let's say my connectivity to site 3 from both the sites went down. So witness failed and cluster removed the vote of the witness. But the tiebreaker scenario kicks in it identifies that there is even number of nodes, and so it removes, let's say, node 3's vote out. And now, if I lose site-to-site connectivity, the cluster survives on site 1, but the site 2 cluster goes down. And so this scenario was not possible before. So this is an example where how these different features come together to deliver the highest levels of availability. So that was automatic failover. Let's look at manual failover considerations. The punchline is all sites are not equal. One is my DR site, and I understand that manual failover is necessary. So if my primary cluster or my primary site is down, I understand that I have to force Quorum and force start my cluster on the secondary site. Because my DR site or the nodes in my DR site are slightly less important than my primary site nodes, you have to configure node vote weights to remove the votes of the DR site nodes. So what this gives you is the nodes in the DR site are not participating in the Quorum calculations, but they are still receiving the cluster database updates from the primary site. So they are still fully functional members of the cluster. They are simply not participating in the cluster in the Quorum calculations. Because you already have this primary and DR site, all nodes to be equal in both the sites is actually not a requirement in that scenario. You actually decide how many nodes you want in either of the sites. Just make sure all the nodes in the primary site have votes. In terms of workload considerations, it's not exactly a Quorum topic, but it's kind of in line with what I'm talking about. So configuring preferred owners is strongly encouraged as well as recommended, because configuring preferred owners, cluster would be able to keep the workload on your primary site, as well as important resources like your Quorum witness resource would be kept in the primary site. So that way, usage of preferred owners kind of becomes important in manual failover considerations. And as I mentioned, if my primary site goes down, as part of recovery actions, force Quorum and prevent Quorum become important. In terms of witness considerations for manual failover, it's almost similar to, it's actually same as automatic failover. We still recommend you have a file share witness in a third separate site. If you ask me why do I need a third separate site for manual failover, because I already have my important site, the answer is if the primary site goes down, when you try to recover on the secondary site using force Quorum, you may still use the third site file share witness. Otherwise, you have to configure a new file share witness, update your Quorum configuration as necessary. Asymmetric disk witness would also can be used. You may also, by the way, that was the recommendation. You may potentially have the file share witness or the file server running on the primary site, because anyways you want the primary site to win. But consider recovery steps before making that decision. Similar to asymmetric disk witness, consider recovery scenarios. Asymmetric disk witness simply highlights the fact that you have storage connectivity in one site and not really on the other. So, in my manual failover, this is my backup site or DR site. That's my primary site. So I still have 4 nodes, but my 2 of the nodes vote were taken out. The witness has a vote. The primary site nodes have votes. If the backup site goes down, it's no change. Cluster survives. Let's look at the recovery option where, let's say my primary site goes down. It takes down the cluster because it doesn't have enough votes. If it's a temporary outage, force start the cluster on the backup side, start the nodes using prevent quorum on the primary side, and then cluster resumes normal functioning. The force quorum resiliency, the new feature in R2, would greatly help in this scenario. But let's say what happens if there is a long-term outage and you cannot recover primary side. And so same things happens, cluster goes down. You force start the cluster on the backup side. You, as part of those steps, you actually assign the votes back to the backup nodes. Because you just gave the votes back, the cluster resumes normal functioning. And when you do get a chance, of course, you do remove the node's vote from the primary side. So essentially, you just exchanged the backup and primary side role as part of this recovery step. And this is a long-haul recovery, but this is only in the scenarios where you cannot really recover your primary side quickly enough. And once you do get access, start the primary side with prevent quorum, and cluster resumes normal functioning. So that was the DR setup. And so the big question really for DR is, what's your SLA? Like, do you want manual failover or automatic failover? In answer to that would determine a slight differences in your quorum configurations. Dynamic quorum, as well as the dynamic quorum for witness, helps in increasing the availability of your cluster, and by extension, the availability of the applications. And in terms of quorum configuration, with the updated quorum wizard, with the simplified terminology, we hope that the experience to configure a cluster quorum is greatly simplified. If you don't, then please send us feedback so that we can actually make appropriate changes. At this point, I'll open up for questions. I know we are a little over, but if you have questions. All right, thank you very much, and my apologies for running over by a couple minutes.